Welcome back, my dear students, to the live classroom. My teacher, we were into the process of discussing some concepts on class 10 physics, and 2 we were focusing certain areas of refraction. So let me recap what we have just discussed. First, you must be familiar with reflection and things related to that. Then refraction, some daily examples of refraction we have just mentioned before the break. Then the refraction is what is made use of in lenses, convex lens, concave lens, and the lens equation and equation for magnification. What exactly you have in the syllabus, or what exactly you have to study for the exam point of view is what I am mentioning now. Okay, then the lenses, after which we have just discussed the concepts of the human eye, the structure of human eye. But in human eye we have the different parts, and there are certain problems or certain defects that we may come across or we may face as far as human eye is concerned. So I'll just show a small video related to the defects of eye. Just listen the video very carefully and understand what are the concepts. If any questions you have related to that, you can ask, you can call us and ask. Plus, after the video we will move on to some of the board paper questions which would be useful for you to solve. Okay, so now first you watch this video very carefully. That will indicate the defects of eye. Watch the video.
Light enters the eye through the pupil, which works much like the shutter of an automatic camera to help us adjust to brighter or darker conditions. When we need more light, the pupil opens wider. When we need less light, the pupil becomes smaller. Light rays entering the eye also must be bent into a precise point of focus on the retina, found in the inner back of the eye. When this doesn't happen, our vision is blurred. Eyeglasses and contact lenses sharpen focus by bending light and changing the way it enters the eye. But why do we have blurry vision in the first place? Well, when you're farsighted, your eyeball is too short. This means that light rays reach a point of focus beyond the retina. In this case, you see blurry images up close. But when your eyeball is too long, light rays achieve a point of focus before they can even reach the retina. This means you are nearsighted and objects appear blurred in the distance. Many eyes also have an irregularly shaped cornea, which is the clear part of the eye's surface. When this happens, light rays can have several different points of focus. This is called astigmatism, which also causes blurry vision. If you want to...
Hope you have seen the video. So the video indicates, or it shows about three different defects, namely nearsightedness or short-sightedness, or it's also called myopia, then farsightedness or long-sightedness, or it's also called hypermetropia, and further we have the astigmatism. So remember, the way you rectify them, that also something which you could understand. The myopia or short-sightedness, it can be rectified with the help of a concave lens, diverging lens of suitable focal length, because exactly it is to be made to focus on the retina. So if the eyeball is long, or let's say the lens is of short focal length, what happens is the rays will not be converged exactly to the retina itself. Instead, it will be converged at a point in front of the retina. So this problem is what is termed as short-sightedness, for which we will have to throw the light rays further away to make it meet exactly onto the retina, for which we are going to use a diverging lens of suitable focal length. Alright. Whereas farsightedness, it can happen due to the shorter or size or smaller size of the eyeball, or low. Even if eyeball is small, normal size, the lens may be of long focal length, so that you will not be able to focus exactly on the retina. It will be further away, further beyond that. So we want to bring it closer towards it, so that it should be made exactly to meet onto the retina, for which we are going to use a converging lens or a convex lens of suitable focal length. Suitable focal length, exactly, it is to be made to focus onto the retina itself. That's how we rectify the problem of farsightedness or hypermetropia with the help of a convex lens or converging lens of suitable focal length. Then we have another issue, that is about the astigmatism, which is in a non curvature, or it is not, the cornea is not perfect, curved. So what happens is, as you have seen in the video, you can see that it will be the images would not be formed exactly onto the same point. It will be neither at that point nor this point, like, you know, there will be blurring of the image in that way as well. So this can be rectified with the help of a suitable lens, what is called as a cylindrical lens. So cylindrical lens, so to sum up, cylindrical lens of suitable focal length to rectify astigmatism, converging lens of suitable focal length to rectify hypermetropia, and diverging lens of suitable focal length to rectify myopia. I hope it is clear. Now I think it's a time for us to discuss some questions, which usually with some of the questions I have taken from the board papers. So first you look at the questions, and before that first you look at the some of the equations as well. So watch this monitor. So the questions from some board papers. So look at the screen and see the equations basically require. We require radius of curvature is twice the focal length only for mirrors. Then those equations, have a look at these equations. The reflection 1 by v plus 1 by u is equal to 1 by f. Then equation for magnification, h dash indicates the height of the image divided by height of object is h is minus v by u. Be very clear, for a mirror magnification equation is m is equal to minus v by u. Whereas for refraction we have speed of light in medium 1 to speed of light in medium 2. You can make out from that. Then for lenses the equation is 1 by v minus 1 by u is equal to 1 by f, and magnification is v by u, and also for lenses we have the equation power is equal to 1 by f. This equation I have showed you already, but this equation, that is p is equal to 1 by f when we write, that is basically to calculate the power only if the focal length is in meters. So you look at the board, we have in addition this equation 1 by p is equal to 1 by f. Power is reciprocal of focal length, but remember this focal length must be in meters. So for example, if focal length is 20 centimeter, if it is given like that, so what will be, how do you have to first convert it into meters, 0.2. all right, then only you calculate power 1 by f. So 1 by 0.2, that is 10 by 2. So how much it is? 5. You know the unit of power is diopter. Okay, diopter. So if the focal length of the lens is 20 centimeters, it means you are calculating the power as 5 diopter. The lens has got a power of 5 diopter. Sometimes the value of the power will be given in the question and you have to calculate the focal length, but we make very clear there again. When you calculate focal length from power, say for example power is given as 5 diopter, what will be the focal length? 1 by 5. But that value 0.2 you are getting is in meters, because everywhere else we are calculating the focal, or we are taking the distances, object distance, image distance, focal length, everything you take in centimeters. But only in this case when you calculate the power, we have to have the value of the focal length in meters. Be very clear on that. So two things where you may make mistake is one is this one. So be very clear. Again I would like to draw your attention at this point. Two common mistakes we may make is, number one, the calculation of power. Focal length must be in meter, or if focal length is to be calculated from power, that value of focal length should be expressed in meter. All right, when you use the equation p is equal to 1 by f, the bulb should light up. Okay, focal length should be in meter. Okay, that's one thing. Second problem or second common mistake I have seen is about calculation of magnification. So magnification is minus v by u you have to use if it is mirror, whereas plus v by u if you could use if the case is about lenses. Clear? Okay, now move on to the next slide, and there are some more points related to the content. The sign convention is another area where you have to be careful about. That is, u is always negative. Okay, h is always positive. H means height of the object. Okay, then focal length, concave. Just make a note on these points. Concave lens or mirror. Both mirror and lenses together I have taken, so you can see that. Okay, m and height of image, magnification and height of image. If it is real, it is negative. If it is virtual, it is positive. Whereas the image distance case when comes, there is a difference when you talk about lens and mirrors. For mirrors, V is negative for real image and positive for virtual image, whereas for lenses V is positive for real image and negative for virtual images. So, these points which I had just now showed you is those points you have to be well clear with in approaching the numerical problems. You look at the next one, some questions we have now. Just read the first question. The absolute refractive indices of glass and water are 1.5 and 1.33 respectively, right? In which medium does light go or travel faster? Calculate the ratio of speeds in the two media. Okay. So, what is given is the refractive index of glass is given as 1.5 and refractive index of water is given as 1.33. So, what you're going to find is, first question is, in which medium does the light go faster? In which medium does light travel faster? So, what is the equation for refractive index? We have C by V. C is speed of light in vacuum, and V, that which is a constant, 3 times 10 to the power 8 meter per second, you know that, and V is the speed of light in the given medium. So, what do you make out from this is, the greater the value of the speed, the greater the value of refractive index, smaller should be the speed in that. The greater the refractive index of the medium, smaller is the speed. So, that means light travels faster in water because the refractive index is less. Or you can even write V is equal to C by N. The smaller the value of refractive index, the greater is the speed. So, what is the meaning? Light travels faster in water. Now, one more question asked is, you have to find out the ratio of their speeds in the two media. That is, the speed of light in glass divided by speed of light in water. Speed of light in glass divided by speed of light in water. You know, speed equation is what? C by N. It is inversely related to or inversely proportional to the refractive index. So, C is the constant. So, that will be cancelled off when you take the ratio. So, speeds are inverse ratio of their refractive indices. That means it would come like 1.33, which is the refractive index of water, divided by 1.5. This is the refractive index of the glass. So, this is the ratio of speeds. Or if you want to find the ratio, actually 1.33 is in fact 4 by 3 now. Okay, and 1.5 is 3 by 2. So, we get what? 8 by 9. That is, ratio of speeds in the two media, we get 8:9. 8:9 is the ratio of the speeds of light in glass and then in water, the ratio. I hope it is clear. Now, look at the next question. Look at the next question. Draw a ray diagram to show the path of the refracted ray in each of the following cases. So, you are asked to draw diagram. Read the question very carefully. Ray diagram to show the path of refracted ray in each of the following cases. The ray incident on a concave lens parallel to the principal axis, passing through optic center and is directed towards the principal focus. So, remember, the question asked is about concave lens. A ray incident on a concave lens parallel to the principal axis. So, first you draw concave lens, then you draw principal axis parallel to the principal axis. Okay. So, this is principal axis. If a light ray parallel to the principal axis, if it comes like this, how will it go after refraction? It will go in such, it will diverge a bit. It's a diverging lens, correct. So, to draw this one, you can say this ray will go like this, as if it is meeting over here. This is the focus. I hope it is clear. So, what is the question? To draw a ray of light incident on concave lens parallel to the principal axis. After that, how it will go. So, this is the path. Okay. How about if it is passing through optic center? Optic center, if a light ray is passing like this, what happens is the light ray through the optic center will go without any deviation. This is the second one. How about if it is directed towards the principal focus? This is the second answer. So, once again, what is the question? The light ray passing parallel to the principal axis, how it will go after refraction through it? Yeah, you can see the question. Then, if it is a concave lens, this is a concave lens. Okay. Second is ray through the optic center, and third one, what you have to draw is directed towards its principal focus. So, towards the principal focus, if the ray is directed. Okay, how will it go actually? So, that is directed towards its principal focus. So, that is the light ray coming like this. So, it is as if it is coming towards the focus or to the focus. So, what happens is it will go parallel to the principal axis. So these are the three diagrams we have, right? So now we look at the next question. See the question number number 3. Calculate the magnification of the image of an object placed perpendicular to the principal axis of convex mirror of focal length 15 centimeter if the object distance is 20 centimeter from the mirror. Object distance is 20 centimeter from the mirror, focal length is 15 centimeter. What's the magnification? Now listen. See, the question is, the object is placed at a distance of 15 centimeter from the mirror. So by the way, when you get the questions of this sort, very first thing you have to check is it a lens or a mirror? Then you have to tune with the equations. Is it a mirror or lens? Alright. If it is mirror, you check if it is convex lens or concave lens. Sorry, if it is mirror, you check if it is concave mirror or convex mirror. If it is lens, again you have to make sure if it is convex or concave. Okay. So first you look at the question, convex mirror, it is a mirror. Okay. And to what kind of mirror? Convex mirror. Convex mirror means focal length is positive. Then you have to think of sign convention. And the object distance is always negative 20. So what we are going to find is the magnification. So what we will do is, we know the equation for, recollect the equations. This is a way to make out about it, approach the numerical problems. Minus V by U. So to get value of minus V by U. I'll just tell you without, in a single step, we can do it in this way. I'll quickly tell you because the time is going to be up. So we will finish off this question very fast. We have, if you can multiply it throughout by U. U by F is equal to 1 plus U by V. So minus U by V is equal to 1 minus U by F. Okay. So minus U by V is equal to F minus U divided by F. Okay. So minus V by U is equal to F by F minus U. Why minus V by U we have taken? Because minus V by U is the equation for magnification. So again we will write it as M is equal to F by F minus U. Okay. So M is equal to, so I will write the equation here, M is equal to F by F minus U. See, this is the equation we are getting for magnification in terms of object distance. Now we just substitute the values here, that's it. 15 divided by 15 minus 20. So 15 divided by 35. Okay, so that much is the magnification. So remember, it is a convex mirror. So we get a diminished image always. That's the reason why we are using convex mirrors as rear view mirrors, because wherever the object is, we will always get diminished virtual images. Anyway, now the time for this session is going to be over. So I would like to wind up today's class. I hope you understood some of the points, and again more questions we are to discuss. We will find some time on a later stage. In case if you want me to explain certain things of this your subject of class 10 or even class 11 or 12, any portions, if you want me to explain, you can mail us or you can call us and say, okay, this portion we want to discuss. So feel free to get back to us so that we can mold our classes according to your requirement. Anyway, nice to have a session today again, as it is the first day of the year 2015. I again wish you a very, very happy and prosperous new year to all the viewers of NTV and my dear students and my dear colleagues as well of Sharjah Indian School. I wish you all the very best throughout this year. Okay, let's finish off today's class. So we will see again next week with another portion, another topic, maybe 10th or 12th depending upon your request. Okay, we will see again. Stay tuned with NTV. Thank you.